So, hi everyone, my name is Micah. I actually just joined Cloudflare 2 months ago as part of the acquisition of my stream processing startup. So I'm super excited to be here talking about how we're actually building a data platform at Cloudflare. So first, hopefully most of you know, but we'll overview what is Cloudflare. I think this is kind of like a giant internet-scale computer. It runs basically everywhere. It has servers in like 300 cities and 125 countries, which is definitely more than I can name. It originally was like a security platform, so we were helping websites survive DDoS attacks and other internet security attacks. And from there, it kind of grew into a CDN, a content delivery network. We realized we have servers everywhere, so we can use them to cache content close to our customers' users. And then we realized that we were kind of building all these applications on top of the CDN, on top of this distributed infrastructure. So if we were getting so much value out of that, like maybe our customers also would get value from doing that. So we built the developer platform, which today has this like vast constellation of services, which let you do everything from build applications, use databases, these days do AI, and use GPUs. And you can deploy all of this stuff basically to the internet, not like a region, not to a colo, but everywhere. And Cloudflare will figure out how to scale it and how to deploy it close to your users. But that doesn't really explain like why we're at Snowflake, why we're doing data talks. I think to explain that, it'd be helpful to kind of go through a little bit of history. So back in the day, like 1985, you had a database. This is before I was born, so I'm a little fuzzy on the details. But you know, it did transactional processing, it did analytical processing. It probably cost like $5 million a year to run and help pay for Larry Ellison's private Hawaiian island. And you know, this was good, particularly if you were Larry. But there was a problem, which is that our data started getting bigger. And that's okay, we just vertically scale. But at some point, you hit a limit just trying to vertically scale. The other thing we discovered is that a lot of the load on our database was actually from analytical processing. And we could get benefit from splitting off our analytical workloads into a specialized system. And quickly this turned into this like complex distributed architecture where we had this distributed file system, and we had Hadoop, we were writing Java to try to process it. And you know, this was okay, but as anyone who's managed a distributed file system knows, someone in the front here who's done that, this really sucks. You do not want to run a distributed file system, and also you don't want to write Java to do data processing. So we started buying cloud data for that, and this was also great. We could just like give them our data. They had these efficient SQL query engines. It was more or less serverless. We didn't have to worry about it. This worked especially well for like the cloud infra companies whose revenue, looks like this. Presumably their CEOs can now buy their own private islands. But what we found as users was that, we wanted these modern SQL query engines, we wanted this like serverless operational experience. But in giving these cloud companies all of our data, we were now like totally locked in. They had our data, so we had to pay the cost of storing that data, and also we had to pay their compute costs. And in the meantime, there's been this huge explosion of modern query engines. You don't have to go to Snowflake or to Databricks to get a really good SQL query engine. They're just all over the place. And it turned out that didn't help you because like our data was still locked in to Snowflake and to Databricks. But there was an answer, which came in the form of a 20-year-old storage technology. If we took object store in form of, for example, Amazon S3, combined it with a columnar storage format like Parquet, we could actually get back control of our data. we could just write all of our data onto our own cloud object store and bring the tools to that data. And this was great. We could use whatever query engine we wanted. We could connect it to whatever cloud processing engine we wanted. And we could only compute, and we had no lock-in. So this is great, but what does that do to Cloudflare? What's the CDN company doing here? And the answer is there's sort of a problem with this nice picture I've drawn here, which is that cloud vendors actually make a large chunk of their money by charging you for egress. Basically, get data out of the cloud, they're going to make you pay, in the case of S3, like 9 cents per gigabyte. And so it turned out, actually, this was just another form of lock-in. You can't actually bring your other tools, you can't move your data around. Every time you try to access your data, you're going to pay that egress fee. And this is where Cloudflare comes in. So a few years ago, Cloudflare launched R2, which is our object storage system. Initially, this was sort of a complement to our CDN. We figured instead of going out to your origin and caching your images and videos, we could actually just let you store it with Cloudflare directly. But then we realized we have all these carrying agreements, and we have this scale of bandwidth usage that lets us basically treat bandwidth as free in most cases. And then we actually didn't have to charge these egress fees that all the other clouds charge. And once we launched R2 with no egress fees, we've just found the usage of it exploded. And there were all these uses we didn't really expect. For example, people started building data platforms on top of R2. Because you really did get that original promise. You could store your data, you could own it, you could pay only for storage, and you could query it from anywhere with any query engine, connect it to any cloud service. So it turned out, we sort of accidentally built this data platform, and over the past year, we've started intentionally building a data platform. Because it turns out R2 was just kind of a place to put data, which is a useful and important component, but there's a lot of other problems you need to solve to actually have a useful data platform. For example, you need to be able to get data into the data lake, and then you need to be able to find it and query it. And so we recently launched 2 products that kind of solve those 2 ends of the problem. Pipelines, which went in beta in April, solves the problem of getting data into the data lake, and R2 Data Catalog is a managed Iceberg catalog that helps you find your data, figure out the schemas, and tell your query engine how to efficiently query it. So a little bit more about these, a little bit more detail. So sort of pipelines. So the product we launched in April sort of looks like this. We give you an HTTP endpoint, you can post data to it, and it'll land in R2 as you might load it into JSON. It's pretty simple, but a really easy way to just get data into R2. A good injection point will have a couple of properties. One, it shouldn't drop or duplicate data, and it also shouldn't write up too many files. The first one, hopefully, is sort of obvious why we care about that. But the second one, this is really important for query performance. If you have a million small files, you have to do all of those metadata operations on your object store to find them, to figure out if they're relevant to your query. And that's both expensive on an operation perspective and also slow. So we want to make sure we're writing kind of reasonably sized files and not too many. But these seem pretty simple, but actually achieving them is pretty hard. And we're building pipelines so users don't have to think about it. They can just send us data and it will land in exactly once delivery with an appropriate size. But I just want to give you a little sense of what it actually takes to build this. So if we look at what the simplest version of this is you might build yourself, maybe you have a Lambda or a Cloudflare worker that's receiving events, it's going to build up like a Parquet file in memory, and then wait some amount of time, flush it to R2, and then respond back. This works okay, but we're going to end up with really small files if we want to give acceptable latency to our clients. So we need a way to like durably store data while we're ingesting it without actually writing those final files. And for that, we will introduce a durable log like Kafka. This is a place where we can quickly write data, make sure it's durably stored, respond back to our client. And then on the processing side, we can kind of take the time we need to read over that, build up our appropriate size Parquet files, and write them to object storage. There's still some challenges here. For example, what happens if our worker crashes? We can do some offset stuff with our durable log, but it's pretty hard to actually get like the exactly once delivery that we want. The second challenge is what we want to be partitioned data. What if we want to write data out in a certain set of files, like per customer ID or per event type. For that, we really need something more complicated. We need something that looks like a stateful stream processing engine. So for pipelines that we're working on, this is an engine that my team called Arroyo that we brought into Cloudflare. And this is an open source stream processing engine we're working on for a few years, and basically solves this class of problems. It combines a handful of features that together allow you to build these reliable performance systems. It has support for repartitioning data, or shuffling data, so you can get, for example, all the events for a particular customer on one node. It's able to support stateful operators, so we can buffer stuff durably inside of the engine, as well as supporting more complex use cases like windowing and aggregates. And it's able to take consistent snapshots of that state. So if we crash, we're able to recover from exactly where we were with no duplicates or dropped data. And with this, we're able to basically build up whatever partitions of data we want of whatever file size, ensuring that we get those like end-to-end exactly once delivery semantics. Something else that's really cool about how we're building this at Cloudflare is we have this crazy global network of computers. And that means that we can actually deploy these pipelines in a globally replicated way that I think is basically not achievable for anyone else building this stuff. That means that we can receive events wherever your users are with extremely low latency. We can persist them and then process them both locally and globally, and get really good performance while also maintaining that incredible low latency and distribution. So I think that's super cool. We are launching pipelines V1 soon. It's going to extend the current pipeline product with SQL transformations powered by Arroyo, exactly once delivery, and Parquet and Iceberg integration, where it will integrate very nicely with our managed Iceberg catalog, which also launched in beta a couple months ago. We're also iterating on this. We're adding compaction and basically integration with the whole rest of your data ecosystem. So that's what I have. Thanks so much for coming. Also, Phil made me plug the fact that we are hiring a senior product manager to run all this stuff. If you're a product manager and you're interested in data, I think this is an incredible role. We're essentially building a new data platform from scratch. And I think it's an incredibly exciting time to be here. So thank you so much.